now, ladies and gentlemen, how would we finish solving for x? We've got to isolate x. What would we do to both sides? Divide by natural log of 3. So x is equal to the natural log of 5 divided by the natural log of 3. Now a notation, ladies and gentlemen. This is not equal to the natural log of 5 over 3. You have to leave it as natural log of 5 divided by the natural log of 3. Those are not equivalent. This is telling you I take the natural log of 5, whatever that is, divided by the natural log of 3. Versus you're taking the natural log of whatever 5 divided by 3 is. All right. Now, when we talk about our answers, this is an exact answer. So leaving it in terms of natural log of 5 divided by natural log of 3 is exact. Now, you can get an approximate answer by changing this into a decimal. The minute you pick up your calculators and you start typing in ln, it's no longer exact, it's approximate. So if I take the natural log of 5 and divide it by the natural log of 3, I end up with, always round to 3 decimal places, I have 1.465. So this is approximately equal to 1.465. Again, this is your approximate answer. It could be either. Exactly. So again, this could be either a calculator or no calculator. Obviously, if it's no calculator, your answer will be an exact form versus the approximation. All right. So any questions on 3A? So let's take a look at 3B. Again, you always still try and rewrite to the same base. Is it possible to take 5 and write it as a base of E? No. So what are we going to do to both sides of the equation? We're going to take the natural log. So natural log of e to the 2x is equal to the natural log of 5. So now I can use my power property of logs. I can pull that 2x out of my exponent. So I have 2x times the natural log of e is equal to the natural log of 5. What is the natural log of e equivalent to? The natural log of e is equivalent to something. You can simplify that. Natural log of e is just 1. This is just 1. So I have 2x times 1 is equal to the natural log of 5. Or just 2x is equal to the natural log of 5. And then how would you solve for x? What would you do to both sides? Divide by 2. So then x is equal to the natural log of 5 over 2. Now, especially if this is multiple choice question, ladies and gentlemen, natural log of 5 divided by 2 can be written in another format. It can be written as 1/2 times the natural log of 5, just so you can recognize that these answers can be written a lot of different ways. Again, natural log of 5 divided by 2, remember, is equivalent to 1/2 times the natural log of 5. Is this answer exact or is this approximate? Remember what a logarithm is? Remember what this is telling you to do? You're solving for the exponent for the base. What is the base of this logarithm? What is the base of the ln? E. So it's actually e to what power is equal to e to the first. So then, again, is this answer natural log of 5 divided by 2, is that exact or approximate? Exact. So again, your approximation can be found by taking your natural log of 5, dividing by 2, which is a 0.805. And again, I'm writing it both ways for you just so you can see.
So it's always approximate from
No. Any answer can be approximate or exact. So any questions on B? Let's take a look at C. Again, we have 2 to the x is equal to 3 raised to the x minus 1 power. Now, I've been using natural log, but you can take the log of any base on both sides of the equation. So we know we cannot take 3 and write it as a base of 2, correct? So I know I'm going to have to now get these variables out of my exponent. You can continue using natural log of both sides of the equation, or to make your life a little easier, what you can do is take log base 2. So notice I have a base of 2 and I have a base of 3. What you can do is kind of an eeny, meeny, miny, mo. You can do log base 2 or log base 3 at both sides. So I typically use the smaller base. So now I'm going to take log base 2 of both sides. So log base 2 of 2 to the x is equal to log base 2 of 3 to the x minus 1. Because one of my exponentials had a base of 2. Yeah. You could have done log base 3 as well if you wanted to. So now I can use my power property of logs. I can write this as x times log base 2 of 2 is equal to x minus 1 times log base 2 of 3. And what is log base 2 of 2 going to be equal to? Kind of like what we just did with natural log a. Log base 2 of 2 is going to be equal to what? 1. So I have x is equal to the quantity of x minus 1 times log base 2 of 3. Remember, log base 2 of 3 is just a number. It's an ugly number. It's a decimal, but it's a number. It is a number. This is a number. So we have a number multiplied by the quantity of x minus 1. So any thoughts on what we would do? If this was like just a number 3, what would your instinct be? You would do what? You would simply do distribute. So I have x equals log base 2 of 3 times x minus log base 2 of 3. So now, notice, what are you trying to solve for? You're trying to solve for what? X. You've got an x on this side of the equation. You've got an x attached to this log base 2. So again, anytime you solve any kind of equation, you always want to gather your variables on one side of the equation, correct? So I'm going to subtract log base 2 of 3x. So x minus log base 2 of 3 times x is equal to negative log base 2 of 3. This is a strategy algebraically you're going to have to get used to. You have an x in this term, you have an x in this term. So how can you get the x by itself? Well, what can you do? What can you pull out of everything on the left-hand side? You can yank out a what? An x. So you're going to factor out your x. So I have 1 minus log base 2 of 3 equals negative log base 2 of 3. Now in your final step, how can you get x by itself? Divide. Here's your answer. Is that exact or is that approximate? Exact. So then your decimal approximation. Again, if you want to use your fraction bar, if you have the updated 84, remember, I would recommend using that fraction bar under alpha y equals. That way you don't have to worry about your parentheses. Negative. Now remember, if you've got the updated 84 where you can find log base 2, that's under alpha window, go to option 5. Log base 2 of 3 divided by 1 minus, again, alpha window, go to 5, and that gives you log base 2 of 3. So you get about 2.718. It is. Now, typically, like I said, I just did this log base 2 to show you. You can solve these log equations taking the log of any base of both sides of the equation. When you are checking your homework tonight, your answers may not look exactly like the answer key. And that's because, again, depending upon what base you use. So if your answer does not match what the answer key is saying, get the approximation, type it in, and see if they're equivalent. Because there's a lot of different ways you can actually write these answers and have them be equivalent. I could have done this problem completely differently by taking the natural log of both sides of the equation. And then your answer is going to look completely different than what I have right here. But there, again, if you get the approximations, they'd be equivalent. All right, any questions on that? So let's take a look at D. 3 raised to the 1 minus 2x equals 5 raised to the x plus 5. So just to show you, I'm going to go ahead and take the natural log of both sides. Could I have done a log base 3 of both sides? Yes. Could I do log base 5 of both sides? Yes. I mean, you have those 3 options. You can do a natural log. You could even do a log base 10 if you wanted to. All right. So, but I'm just going to take the natural log of both sides. So the natural log of 3 raised to the 1 minus 2x equals the natural log of 5 raised to the x plus 5. Again, now I can use my power property of logs. 1 minus 2x is equal to the natural log of 3 equals x plus 5 times the natural log of 5. Why did it do equals? I don't know. This should be times. There. Yes, 1 too many equal signs. Okay. Now, there's a couple different options. Again, natural log of 3 is just a number. Natural log of 5 is just a number. All right? You could distribute both of those into the parentheses, or what you could do is just, again, you could divide both sides of the equation by either the natural log of 3 or the natural log of 5. Again, somehow, some way, you're going to get rid of the parentheses. We are going to have to end up distributing eventually the natural log of 3 and the natural log of 5. You can make it a fraction and distribute a fraction, or you can distribute the natural logs as they are. That's, again, they're equivalent. You can do either. I'm going to go ahead and just distribute both natural log of 3 and natural log of 5. So I have natural log of 3 minus 2x times the natural log of 3 is equal to x times the natural log of 5 plus 5 ln of 5. Just like I did in the last problem, I've got an x, a term that has an x on the left. I have a term that has an x on the right. So what you want to do is you want to bring everything that has an x on one side of the equation, move everything else away from it. So what I'm going to go ahead and do is I'm going to move this 2x ln of 3 to the right-hand side of the equation. So I'll have the natural log of 3 is equal to 2x times the natural log of 3 plus x natural log of 5 plus 5 ln of 5. So all I did was I moved this minus 2x ln of 3 to the right-hand side of the equation. So now notice at least I have all my x's on one side of the equation. So I want to isolate. I want to make sure everything on the right-hand side has an x. So what do you think I'm going to have to do with this 5 ln of 5? I'm going to do what? Subtract it. So I have the natural log of 3 minus 5 natural log of 5 is equal to 2x ln of 3 plus x ln of 5. Now, everything on the right-hand side of the equation has my x's. So just like I did in the previous problem, what can I factor out of the right-hand side? I can factor out what? X. So now that I factored out my x, how can I solve for x? I can do what? Divide. There's your exact answer. Okay. Now, just so you know, there's a lot of different ways you can see this answer written. Just look at the numerator. And again, if this is a multiple choice, they're going to use all these property of logs on you. How can you condense the numerator? Are there properties of logs you can do to condense that numerator? Sure there is, exactly. What are these coefficients? Where would this 5 go? Exponent. And how do you condense through subtraction? You condense it through what? Division. So another way you can see this answer written. So I'm just bringing it to your attention because you don't know if it's a multiple choice test what properties of logs they're going to use on you. So again, the natural log of 3 divided by 5 to the 5th.
They're not giving us one on you.
You've always had a couple.
A couple of them.
That's what I mean, a couple questions here. How would you condense the denominator? How would you condense this denominator? You could write it as what? How could you condense this? ln of 3 to the 2nd times what? 5. So again, that's the tricky part about these logs, is the fact that the answers can be written a lot of different ways. It all depends upon A, what base logarithm was taken on both sides of the equation, and then B, how are they cleaning up the answers? What properties are they using to clean up the answers? So just recognize that when if you're working with a friend and your friend's answer looks one way and yours looks completely different, it doesn't mean that you're wrong. It's just depending upon which base logarithm you decided to start the problem and which properties. Now again, if it's free response, I'm okay leaving it without using any properties. But again, you have to be able to recognize your answers because we put in a lot of different forms. Yes, Matt? Yeah, it's over here on the right. Yeah, I just did right all over again. So So it's just x equals this. That's it, because this is going to cancel out. So it's just, this is all equal to x on the right. Because you factored it out, and then when you divide, that's going to give you a 1 here. So the x is on the right hand side, and this is all your common answer. Any questions on D? Uh-huh. Like right here?
Yeah.
I'm just showing you different ways to write your answer. What do you mean the same thing? Well, this you can't, there's no more simplifying you can do on this answer. You can't do anything else. Remember what I said, this natural log of 5 divided by natural log of 3 is not equal to the natural log of 5/3. But if you look at this numerator, if you look at your answer, just the numerator in itself, you have 2 terms of logs in it. So you have this property, your addition and subtraction property of logarithms that you can condense it. Again, just the one thing you have to be able to do is you have to look at your answers and realize that there's a lot of different equivalent ways you can actually write these answers. So your answer may not match like your friend's, it may not match the answer key, but the question is it equivalent? And that's the thing with logs, they use a lot of properties of logs. All right, let's take a look at E. So again, in letter E, first of all, just like any equation, you always want to isolate the variable. So right now you have this e to the negative 4x that's being multiplied by 1,000. You want to isolate e first. So what can you do to both sides of the equation? Divide. So we have e to the negative 4x. And 75 divided by 1,000 is 3 over 25. 3 or 40, yeah.
What about 4? -4.
Oh yes, negative 4x. That's for negative x. Thank you. So first step, so if the base that has the variable is not by itself on one side of the equation, you want to isolate it first. Now what can you do to both sides of the equation? You can do what? ln. The natural log of e to the negative 4x is equal to the natural log, and make sure you put parentheses around that 3 over 40. So I have negative 4x times the natural log of e is equal to the natural log of 3 over 40. And again, remind me, what is the natural log of e equivalent to? The natural log of e is what? 1. So I have negative 4x is equal to the natural log of 3 over 40. And then what can you do to both sides of the equation? You can do what? Divide by negative 4. So x is equal to, again, this can be written as negative 1/4 times the natural log of 3 over 40. Or, let me write another way you may see this answer. How come those two answers are equivalent? How come those are equivalent? You took, yeah, a lot of times, ladies and gentlemen, you will never see a negative number, a negative coefficient in front of the natural log because of those power property of log. Remember what happens, I can actually take this and raise it to the negative first power by using your power property of logs. And by raising this to the negative first power, I would take the reciprocal. So these answers are equivalent. So again, a lot of times you won't see that negative coefficient in front of the log. All right, any questions on E? So now let's take a look at F. Where is F? He's buried. So e to the 2x plus 6e to the x minus 7 is equal to 0. First of all, when you see, and get used to this, when you see an exponent, and it's an exponential equation, and you see this 2x, no longer is a linear equation. This is a quadratic equation. And how do you always try and solve quadratic equations? You always try and solve by what? Factoring. Remember, we talked about this when we solved our trig equations. What makes a quadratic equation is when you have a base raised to a second power. So if you look at this e to the 2x, another way I could write e to the 2x is e to the x raised to the second power. Would you agree with me that e to the 2x is equivalent to e to the x to the second power? Plus 6e to the x minus 7 is equal to 0. Now, just like we did with the trig equations, if you have no idea how to solve it, or you do not like seeing this equation written in terms of e to the x, do that substitution. Let's just let y be equal to e to the x. Let's just take out that e to the x altogether, and let's replace it with a y for right now. So that would give me a y squared plus 6y minus 7 is equal to 0. To get you through the algebra part in terms of the factoring. So hopefully we all know how to factor y squared plus 6y minus 7 equals 0. Yes? How do you factor this? This is going to factor into what? Y plus 7 and then a y minus 1 equals 0. And then what do? You set each factor equal to what? 0. So y plus 7 equals 0, y minus 1 equals 0. And then when you finish solving it, what's y going to be equal to? Y is equal to what? Negative 7, and then y is equal to 1. Is that my final answer? No. So now remember, this is where I've got to bring back in that e to the x. So e to the x equals negative 7. E to the x is equal to 1. Okay? So like I said, the thing is, anytime you see that exponent of 2x, and it's an exponential equation, you need to recognize that as a quadratic equation, because that's what you have. So if you do not like seeing the quadratic equation written in the terms of e to the x, or if it's a 2 to the x, or something like that, do this substitution to get you to the factoring part. All right, and then you can bring back in that exponential part at the end. So now, how do you solve e to the x equals negative 7? What are you going to do to both sides of the equation? You're going to take the what? ln. So natural log of e to the x is equal to the natural log of negative 7. Do you recognize a problem? Can you take the natural log of a negative number? No. So this part doesn't have a solution, because remember, you can't take the log of a negative number. So now when you take the natural log of e to the x is equal to the natural log of 1. So now what can you do with that x? You can take it what? So x times the natural log of e is equal to the natural log of 1. And again, what is the natural log of e equal to? The natural log of e is what? 1. So x equals the natural log of 1. And by your property of logs, what is the natural log of 1, or the log of 1 of any base? Changes into exponential form. What's that look like? The base of this logarithm is what? E to the x is equal to 1. What's x going to have to be equal to? 0. Remember, any base raised to 0 power is 1. You've got to remember, guys, natural log of 1 is 0. And the reason why is because of this. Remember, you're solving for the exponent for the base. All right? So like I said, with the quadratic equations, guys, when you see that 2x, you've got to recognize that you're dealing with a quadratic equation. All right? So any questions on F? Okay? All right, so we good on that? All right, let's take a look at G. So for G, we have 2 to the x minus 1 is equal to 5 to the 2x plus 6. So, suggestions. What are we going to do first? Take the ln of both sides. So natural log of 2 raised to the x minus 1 is equal to the ln of 5 raised to 2x plus 6. So now what can you do? What's next? Move the exponents out. So again, make sure you leave that x minus 1 inside parentheses. Make sure you leave that 2x plus 6 inside parentheses. Then what? Distribute. So I have x times the natural log of 2 minus natural log of 2 is equal to 2x natural log of 5 plus 6 natural log of 5. Now, I have an x on the left and an x on the right. So what are we going to have to do? Bring them on one side. It doesn't matter, eeny, meeny, miny, mo, which side you want to bring all your x's over. I'm going to go ahead and bring everything over to the left, all my x's. So x ln of 2 minus 2x ln of 5 minus natural log of 2 is equal to 6 ln of 5. So all I did was I took that 2x ln of 5 and I moved it over to the left. Now what? What do you think we should do next? What do you think we should do next? Add ln of 2. So I have x ln of 2 minus 2x ln of 5 is equal to 6 natural log of 5 plus natural log of 2. Remember, you want to make sure you isolate. If you've got an x in more than one term, you want to make sure that you bring everything that has an x on one side and move everything else away from it. Because now what can you do? What can you take out of the left-hand side? You can take out a what? X. And then finally, last but not least, how would you get x by itself? You would do what? Divide. And there's your answer. Oh, there's lots of ways you correct this. Could you condense the top or condense the bottom if you wanted to? Yes. Again, remember, is this an exact or is this an approximation? Exact. Remember, you can get an approximation by typing it in your calculator, or if your answer does not match what you're seeing on the answer key, type this in your calculator and see if it's equivalent. So again, remember, I definitely recommend using that fraction bar, which is located under alpha window, alpha y equals, excuse me. So you have 6 ln of 5 plus natural log of 2 over natural log of 2 minus 2 natural log of 5. So negative 4 point, when I round to 3 decimal places, that's going to be negative 4.098. So any questions on G? So let's take a look at H. Well, first of all, you have a fraction. E to the x plus e to the negative x all divided by 2. Just like you do with any equation. Get rid of the fraction. What can you do to get rid of the fraction? What can you do to both sides of the equation? Multiply by 2. So I have e to the x plus e to the negative x is equal to 6. We don't like negative exponents, so let's get rid of the negative exponent. How can you rewrite e to the negative x with a positive exponent? This would be what? Plus 1 over e to the x is equal to 6. I have another fraction, don't I? I got rid of one fraction, I have another one. Well, just like we did in the very beginning, get rid of the fraction. What can you multiply the entire equation by to get rid of the fraction? E to the x. And when you multiply e to the x times e to the x, what does that give you? E to the what? 2x plus 1 is equal to 6 e to the x. I circled and I highlighted this a few minutes ago. What kind of equation are you dealing with? Linear or quadratic? Quadratic. So how do you solve all quadratic equations? What do we want to have on one side of the equation? 0. So e to the 2x minus 6e to the x plus 1 is equal to 0. If you do not like seeing this equation, or you have no idea what to do with this quadratic equation, what can we take out and replace it with just a variable? What can we do? Yeah. You just take out your e to the x and replace it with a y. If you don't like seeing it in terms of e to the x at this point, take it out. And write it as a y squared minus 6y plus 1 equals 0. So, can you factor this? No. So now you got to fall back on one of your other ways to solve quadratics. What other ways do we have to solve quadratics? Complete the square, or you could use what? Quadratic formula. This is actually set up very nicely for completing the square, and it would be quicker. So remember, with completing the square, what's your first step? What are you going to do with this plus 1? Move to the other side. So now remember, how do you complete the square? You take this negative 6, and what are you going to do with it? You're going to do what? Divide it by 2, and then you're going to what? Square it. So negative 6 divided by 2 squared gives you what? What's negative 6 divided by 2 squared? 9. So I'm going to add 9 on the left, add 9 on the right. So now what do you do with the right-hand side? What can you do with the y squared minus 6y plus 9? Factor it. But what does it factor into? Y minus 3 squared, or whatever variable you use, equals negative 1 plus 9 is 8. And then what can you do with both sides? You can take the square root. So y minus 3 is equal to plus or minus, can you reduce square root of 8? What's your final answer? Y is equal to what? 3 plus or minus 2 square root of 2. Like I said, you could have used quadratic formula if you don't like including the square.
When you have to plug
Yeah, we're not done. We're going to place so far where I got the 3 plus or minus 2 square root of 2. Well, now remember, what did I replace? What was y originally equal to? Y is equal to what? E to the x. So this is where now you bring back in your e to the x. Now what are you going to end up doing to both sides of the equation? To what? What are we going to do to both sides? Natural log. Finally, this problem's over. Unfortunately, worst case scenario is you end up, yeah. No, just e to the x. All right, like I said, worst case scenario is you get that exponential quadratic equation where you can't factor it. You have to use completeness. That's like your worst case scenario here. All right. Any questions around that 3 plus or minus 2 squared 2? Now, the big question is, how many solutions do you have sitting inside? How many solutions do we have? 2. You cannot take the log of what kind of number? Negative. I know 3 plus 2 square root 2 is good, but what about 3 minus 2 square root 2? Would that be a positive number or a negative number? You have to check that in the calculator. And you end up with a positive, so they're both good. So just make sure, guys, in your answers, make sure you don't end up with negative numbers sitting in front of the logs when you're solving these exponential equations. You've got to reject them. All right? Let's take a look at, we did a problem like 3, we were doing properties. So they're telling you that log of 3 is 0.4771. And log of 11 is 1.0414. They want you to find the log of 33. Well, look at 3 and 11 and the relationship to the number 33. What can you do with 3 and 11 to get 33? So log of 3 times 11. You agree with me is equal to log of 33. Now, with property of logarithms, how can you break apart the 3 and the 11? What operation can we expand this out with? We can break this up to what? Add. So that this is going to be equivalent to log of 3 plus log of 11. And what are they telling you? Log of 3 is equal to what? 0.4771. And what's log of 11 equal to? 0.414. So now all you have to do is add 0.4771 to 1.441. So just a review of those properties. So it gives me 1.5185. You guys go ahead and try number 4 on your own.